So let's take a look at number 5. Now, why do I separate number 5 from, 5, 6, 7, and 8, these 4 questions from 1, 2, 3, 4? You'll see this in a moment, okay? Now, so again, the exponents is where we find the x, okay? So we need to rescue them. We're gonna bring it down. So the way we bring it down is by using natural log. So I'm gonna save myself a step right here. So I'm gonna bring it down the exponents as well. Are we okay so far? Okay, we use natural log to bring down the x. Lovely. Now, the key challenge right here that's different from the first 4 questions is that now we have 2 places with x. Okay, what do we do now? What do we do now? Now, before I tell you what to do now, or before I show you what to do now, I want you to do a little side problem. Like we have some blank space on the left. Let's go ahead and write this down. Okay, the little side problem is this. If I give you this problem, do you know what to do? Okay, then go ahead and do what you would do to get x by itself. Okay, go ahead. Do this problem on the side. What would you do to get x by itself? What's the first step? You distribute, right? So you have 4x minus 4, and then you have 5x on the left, and then you just subtract 4x, right? So 5x minus 4x is equal to -4, right? Now, of course, 5x minus 4x is equal to x. Now, here's something that I learned from geometry, or from teaching geometry. Okay, remember at the beginning of geometry, you have all those proofs that people usually hate. Do you hate proofs? Okay, but there's one reasoning that it caught me by surprise. When you combine like terms, I mean, we all know this is equal to x, but what is really happening, it's called the distributive property. This is the distributive property. Yeah. And how? The inner works of what's going on here to get x is this. You are actually factoring out the x first. Then you have 5 minus 4, which equals to 1. And that's how you have x equals to -4. Okay, so that's what's happening when you say, oh, let's go ahead and combine like terms. It's actually involving a step called factoring. You factor whatever that is, then you can subtract or add. In this case, subtracting. So easy, right? Easy. Now, what I want to show you here is this. I want to show you that the number 5 and the number 4 right here, the numbers, right? They are just like natural log of 2 and natural log of 3. Now, it takes a little bit of time to become more familiar with this. That's why your practice is going to be very crucial. You will distribute the natural log of 3 into the parentheses. Okay, because log of any number is just a number. And then, well, you see the x term, right? Well, go ahead, put them all to the same side. So x natural log of 2 minus x natural log of 3 equals to negative natural log of 3. And then you will have to factor out the x. Right here. And then what do we do to get x by itself? We'll simply divide it. Because remember, log of any number is just a number. So we will go ahead, divide this number away. So you have x equals to negative natural log of 3 over natural log of 2 minus natural log of 3. Or even better, okay, see if you can conceptualize this. Even better, this negative, it's really some extra work to write. So what you can do is to apply the negative into the denominator. And when you do that, you have natural log of 3 minus natural log of 2. So this will be your final answer. Now, if you give me this one, I'm okay. But as a practice, you should minimize the writing of negative signs because, you know, we all like to forget negative signs. So this is why it is very important to minimize the appearance of the minus sign.